Welcome to week 2, where we're doing recursive functions. And we're also doing pointers. And I decided that it would, just for cleanliness of project's sake, be better to separate the two projects out, especially because I wanted to implement 2 forms of testing into my recursive function program. And again, for cleanliness and simplicity of use of ease and understanding, separate out the 2 programs to make it a little bit easier to understand everything. So without further ado, what we are going to be doing is testing the recursive and iterative functions of a factorial. And factorials are very interesting because in computer science, these numbers can be very large and grow very quickly. And it's quite interesting to see how different CPUs and programs, depending on how they're written, will work with such large numbers when they grow exponentially so quickly. And this is a very, very, very basic program, and it does not encompass an unlimited number of factorials. We're just showcasing what testing can be done on a very basic level and the use of factorials. So without further ado, let's get into the console, and we are asked to ask ourselves to put in a non-negative integer. So to try, we know that the factorial of 1 is 1. And we did our performance tests for our recursive and iterative times. And it computed the nanosecond return for each one of the tests. And we had a test structure of 0, 1, 5, 10, and 15, which each test passed for the unit test. So let's try that again. 1 and 1 is easy. Anybody can do 1 and 1. So let's do 7. Fun number, isn't it? Well, the factorial of 7 came out correct. It's 5040. It passed our unit test, and our running performance test this time was much quicker. And as you notice, as the numbers increase, the n factor times will run a little bit longer. Now again, we're calculating in nanoseconds, so this is very, very, very quick computational speed. And to capture that is not exactly accurate. So 100 nanoseconds or 300 nanoseconds is a ballpark. But we're actually getting some results in our performance testing. So again, let's keep going. Let's do another integer. Let's get larger this time. Let's try 46. And wow, factorial of 46, like I said, these numbers get big, and it calculated both correctly, the recursive and the iterative, and our unit test passed again, and our performance test. Once again, we're showing a higher weight on the larger n scale. To show that we have to enter a non-negative integer, let's just try a non-integer. And that tested that we have an invalid input. What happens if we absolutely want to just break the system? What if we tried to get the factorial of 1,000? I can already tell you right now, that's a big number. And it didn't work. We have not allocated enough space in our code to calculate the factorial of 1,000. I'm actually surprised that it didn't break the program completely. But as you can see, nothing passed and nothing calculated. Other than those higher weighted n numbers. I am actually very, very curious. Let's go even higher. And there we go. We absolutely broke the program. I put in 1,000,000, or I even may have put 10 million, but we broke the program because we do not have a base case for the factorial for the number we entered, thus terminating the program. And you can see where it took us into our code, into the recursive factorial, our first function, and it wouldn't move past that because it does not have the allocation necessary to complete our asked task for our computer. So that pretty much concludes a very, very, very brief demonstration of doing factorials and functions, and also doing two different types of testing methods for our n factorials.